Hey there, this is Mr. Weaver, and this is Unit 2, Lesson 3, and more about the constant of proportionality. After this lesson, you need to be able to find missing information in a proportional relationship using a table, and you need to be able to find the constant of proportionality from information given in the table. You'll know you're successful after this lesson if you can fill in missing information in a table of a proportional relationship, and if you can determine the constant of proportionality from the table. The first part to this lesson is using measurement in proportional relationships. So measurement is proportional. Here we have part of a ruler. On one side we have centimeters, on the other side we have inches. So let's compare our centimeters to our inches. Well, 1 inch on the ruler is the same as 2.54 centimeters. It's the same distance. So in my table, I'm going to write that 1 inch is the same as 2.54 centimeters. If I were to measure out another inch, that would be like measuring another 2.54 centimeters. If I total it all together, then 2 inches is the same as 5.08 centimeters. So in my table, I'm going to put that 2 inches is the same as 5.08 centimeters. If we add a third inch, that would be 2.54 more centimeters. So our totals would be up to 3 and 7.62. Now, going off of this, we should be able to use it to predict what other distances are. If we know how many inches, we can calculate how many centimeters that's going to be. So let's say that I wanted to know 5.36 inches, and I need to know how many centimeters that is. Each time, we have the same ratio. 1 inch is equal to 2.54 centimeters. So that's our ratio, 1 to 2.54. What did I have to multiply by to go from 1 to 2.54? Well, I had to multiply by 2.54. If you know the unit rate, so how much it is for one thing, that number is the same as the constant of proportionality. So here, 1 is the same as 2.54 centimeters. I'm going to multiply by 2.54. So if you can find that 1, it will help you out. So each time, I'm multiplying by 2.54, which means I need to do the same thing to my 5.36. So 5.36 times 2.54 is 13.6144. I didn't round here, but your teacher may have you round off at a certain decimal place. What if we wanted to go backwards? Let's say we knew the number of centimeters and we wanted to figure out how many inches that was. So I'm going to plug in all the ones that I know already and what their inch equivalents are. So 2.54 centimeters was the same as 1 inch, 5.08 is 2, and so on. And I also included 13.6144, and that's the same as 5.36. What if there's 10 centimeters? How many inches is that? Well, what do I need to do to go from 2.54 to 1? It might not seem quite as easy as it was before, but think back to the previous unit. If I go from one shape to the other, I multiply by a scale factor. If I want to go backward, I multiply by the reciprocal scale factor. So 1 over 2.54. Each time, it would be the same. So I would need to do that for my 10. 10 times 1 over 2.54. It's the reciprocal of going from inches to centimeters. So now I'm going backwards, I take the reciprocal. So 10 times 1 over 2.54 would give us 3.937, so almost 4 inches. And as I said, notice the constants of proportionality are reciprocals of each other. Just like in scale factor, if you went forward, you have one scale factor. If you try to go backwards, it's the reciprocal. Using our same numbers, so we already know what the constants of proportionality are, but let's say that we want to be able to figure it out. Okay, maybe you're not given your unit right, so your constant of proportionality is going to end up being what you multiply by, and that is going to be your end over your start. So let's say I wanted to go from 3 to 7.62, and I want to figure out what I multiplied by. Well, I'm going to put my end, 7.62, on the top, and I'm going to divide that by my start, which was 3 on the bottom. So 7.62 over 3, going to divide that out, and I would get 2.54. So that would tell me that I had multiplied by 2.54. This strategy is good to use, especially when you're not given anything easy, like 1. So your end divided by your start. If I wanted to go backwards from centimeters to inches, so let's say from 5.08 to 2, if I do 2 divided by 5.08, or 2 over 5.08, my end over my start, if I reduce that fraction, I end up with 1 over 2.54. So I just divided by 2 on the top and the bottom, 1 over 2.54. They were reciprocals of each other, just like we showed before. In one, I'm going to multiply by 2.54. In the other, I'm going to multiply by 1 over 2.54. So again, the constants of proportionality for going forward and going backward are reciprocals. Next, here we have a map going from Moscow, Russia to Madrid, Spain. So this is from Google Maps, and believe it or not, that is actually a straight line between Moscow and Madrid. The Earth is a 3D sphere shape, so when we try to put it on paper, going in a straight line eventually it'll look like a curve. So it is a straight line from Moscow to Madrid. So now, for this, let's look at constant speed as a proportional relationship. So constant speed is proportional. As you travel, if you're going at the same speed, okay, you end up moving the same distance every time you go that same amount of time. So you're traveling from Moscow, Russia to Madrid, Spain in an airplane. During the middle of the night, you travel at a constant speed over Minsk, Warsaw, Prague, and Zurich, which is not on the map. In the table, you are given some times. We want to figure out our distance and our speed. Okay, and then we also want to figure out the time it took to go from Prague to Zurich. So we are traveling at a constant speed. If you notice here, ignoring our speed column, we have a table where distance is our end and time is our beginning, our start. So if I wanted to figure out my constant of proportionality, I could do my end, my distance, divided by my time, which is also neat because that's what speed happens to be. So speed, if you ever want to calculate your speed, you take your distance that you traveled and divide by how long it took you to get there. So from Minsk to Warsaw, it was 295 miles, and it took 0.54 hours to get there, or about 32 minutes. If I divide that out, my speed ends up being 546 miles per hour. Our speed is 546 miles per hour, which means we had to multiply by 546 to go from our time to our distance. In this case, our speed is our constant of proportionality. In the problem, it says we are flying at a constant speed. And I know you might start off at 0 and you slowly speeding up as you take off, and then you slow down as you land. But in the middle, between these cities, we are going at a constant speed, which means that our speed throughout our flight is 546, which is good that that's constant because that's our constant of proportionality. So I'm going to write that for Warsaw to Prague and Prague to Zurich. We're keeping our speed. If I know that, going from Warsaw to Prague, I can figure out my distance because 546 is my constant of proportionality. I can just multiply by 546. So 0.58 times 546 is 317 miles. If I want to go backward from distance to time, I can't use the same constant of proportionality. I need to use the reciprocal. Going backwards is the reciprocal. So I'm going to multiply by 1 over 546. So if I do 325 times 1 over 546, I end up with 0.6 hours, or about 36 minutes. If we were to go back and look at our map, we could see that these cities are pretty close to being equidistant apart. 32 minutes, 35, 36. Okay. 295, 317, 325. They're all pretty close to being the same distance and the same time. So if we want to figure out our time that it takes or our distance, our speed ends up being our constant of proportionality. And again, to figure that out, we just take our end divided by our start, and we can figure out our constant of proportionality. So in this lesson, we learned that if something's at a constant speed, there's a proportional relationship between the time and the distance. Okay, so here's a lot smaller example of a bug crawling on a sidewalk. The distance it traveled in centimeters and the time in seconds. So it went 3 halves centimeters, or 1.5 centimeters, in 1 second. It went 1 centimeter in 2/3 seconds. We can use our constant of proportionality, which ends up being 2/3, to figure out the time that it takes to travel any distance. If you notice too, we have the 1 in our distance traveled. That's our unit rate. So going forward, our constant of proportionality that we would have had to multiply by ends up being paired with the 1. If we want to go backwards, okay, the columns here were switched, so I know the time and I want to figure out the distance. I would find my 1 and multiply by 3 halves. My constant of proportionality here is 3 over 2. It is the reciprocal of 2 over 3. This is true for all of our proportional relationships. If you go forward from one thing to the other, you get a certain constant of proportionality. And if you go backward, you end up with the reciprocal constant of proportionality. Do you now know how to fill in missing information in the table using our proportional relationship? And can you determine the constant of proportionality from a table? If you're not sure about these things, go back and watch pieces of the video, pausing and rewatching where you need to deepen your understanding of the concept. And that's the end of lesson 3, with more information on our constant of proportionality.